Welcome to Sachu Study Tech. Today topic is insertion algorithm for AVL tree. So these are the simple steps. Insert the new node as a in standard binary search tree. Already we have discussed in previous video what is binary search tree and what are the notations for AVL tree. Okay, these are the notations. You can see insert the new node as a standard binary search tree. Traverse up from the inserted node to the root, checking the balance factor of each node. After adding each node, you have to check the balance factor. If it is not balanced, okay, you can perform appropriate rotation. Now you can see the one example problem, then you can understand that AVL tree, how can create AVL tree for this following case. Now I am consider 16 here the first node. So the balance factor, what is meant by balance factor? Height of the left subtree minus height of the right subtree, that is equal to 0, minus 1, 1 only. Other than that, the AVL tree is not balanced. So have to perform some rotations. Okay. Now here you can calculate the balance factor. The 16 balance factor, left subtree it is 0, right subtree it is 0. So that the balance factor of 16 is 0. Now you can add 20. Okay, where you can add 20? Here you can compare with 16. 20 is the maximum. So that we have to add 20 here because of BST. So the balance factor of 20 is 0. The balance factor of 16 is minus 1. Here it is left subtree is 0, right subtree is 1. So that 0 minus 1, that is minus 1. Now you can add 12. Where you can add 12? 16 here, 20. 12 is added and left, right? So the balance factor is 0, here it is 0, here it is also 0. Now we can add 8. Where you can add 8? Here it is 12, here it is 20, right? 8 is added here. Again you have to calculate the balance factor. It is 0, here it is 1 because of left subtree it is 1, right subtree is 0. So that 1. Here the balance factor of 16 is left subtree it is 2, that is 1 level, this is second level. 2 minus 1, so that it is 1. So here it is balance factor is 0. Okay, is it balanced or not? It is balanced because of 0 minus 1, 1 is there. Okay, so it is balanced. Have to add 50. Where you can add 50? So the 50 is added here. You can compare with the 16. Okay, it is the maximum one. Here 50 is greater than so here it is 16 less than 50, or you can see here it is 50 added on right side. Again you have to compare with the 20 here, we have to 50 here. Okay, again after adding 50 you have to calculate the balance factor. It is 0, here it is minus 1, here it is 1, right? Here it is 0. Here you can see the left subtree it is 2, right subtree it is 2. So that is it is 0. Okay, so it is balanced. Now have to add 6. Where you can add 6? Here it is 16, here it is 12, here it is 20. Okay, 8 is here and 50 is here. Now you can add 6. Where you can add 6? Here you can add the 6 on left. Okay, 6 is added here. Then have to calculate the balance factor after adding 6. So the balance factor of 6 is 0, the balance factor of 8 is 1, the balance factor of 12 is 2. Here in this case you can see it is 2. And also here you can see that means left subtree it is 2 and right subtree it is 0. So that it is 2. So here it is minus 1, here it is 0. You can see height of the left subtree is 3, 3 minus 2, that is 1, right? So you can see that, you can see here it is not balanced. It is not balanced. It is not balanced because of, why it is not balanced? Because of here it is added left and left, left left. So left left notation. So we have to follow left left means, left left means we have to single rotation, that is right rotation, right rotation. RR means right right, have to perform single left rotation, single left rotation. In this case LR and RL, in this case we have to perform two rotations. LR means we have to first you can perform left rotation and right rotation. Here you can see left, that means right rotation and left rotation. Okay, two rotations you have to perform whenever LR and RL is occur. So here you can see LL, that means only single rotation. That rotation is, here the LL is there, have to perform right rotation. Right rotation means just here you can see, okay, right rotation, just tag the thread here, pull down in right direction. Okay, pull down in right direction. You can perform here, you can see it is 16, and whenever you can pull down here in right direction, 8 become 8 is the parent of 12. Okay, it is 12, right? It is 6, and then here it is 20, here it is 50, right? So again you have to check the, is it balanced or not. Here the balance factor of 6 is 0, here the balance factor of 12 is 0, balance factor of 8 is also 0. Okay, here you can see the balance factor of 16 is also 0, because here the left subtree height is 2 and right subtree height is also 2. So here the 50, so the balance factor of 50 is 0, here the balance factor of 20 is minus 1. Okay, everything is balanced, right? How to add 15, 1 5. Where you can add 15, you can see here, you can compare with this one, and also can compare with 15, compare with 8, so that you can add 15 here. Again you have to calculate, here it is the balance factor is, okay, 0, here the balance factor is minus 1, right? Here the balance factor is minus 1, because here left subtree height is 1, right subtree height is 2, so that it is minus 1. Here also you can see height of the left subtree is 3, you can consider the maximum one, right? So 3 minus 2, that is 1. So here it is minus 1, here it is 0. So it is balanced. Now you can add 13. Where you can add 13, you can compare with this one here 13 is there. So you can add 13 here. You can add 13. Okay, whenever add 13 here, you can check the balance factor. The balance factor of 13 is 0. The balance factor of 15 is 1. The balance factor of 12 is minus 2. Because here the left subtree height is 0. There is no left subtree for 12. So right subtree height is 2. So the left subtree 0 minus 2. That is minus 2. Right? And also have to check here the balance factor is 0. Here the balance factor is, you can see here it is 3. Here it is 1. So that it is also minus 2. Okay, here 1 2 3 4. Okay, height of the left subtree is 4, height of the right subtree is 2, so that this height, the balance factor of 16 is 2, and here the balance factor of 20 is minus 1, here the balance factor of 50 is 0. So it is not balanced, right? It is not balanced, because here first you can solve this problem. First you can solve this problem. What is this problem here? It not solved. Here you can see it is not satisfied the balance factor, because of here it is a right, here it is a left. So that is RL. RL means we have to perform left rotation first and right rotation. Where you can perform the left rotation, you can see here the for example here RL, so that is RL is right and left. So just you have to remember that whenever L is there, here left is there, so we have to perform opposite, that is right. So you have to perform the right rotation in this direction. Just tag the thread here pull down on right direction, so that the 13 here and 15 right of the 13. Okay, now we can see after performing this single rotation here, but here RL is okay, we have to perform two rotations. First we have to perform right rotation. Okay, now I am performing right rotation first. Here it is 16, here it is 8, here it is 20, and here 50 is there. Now we can see left of 8 is 6. Okay, now I am performing here right rotation, that's why 13, and here it is 15. Okay, so right rotation you can after performing right rotation we have to perform left rotation. We have to perform left rotation. So here you can see the right, so that we have to perform left rotation. So we have to perform left rotation. So how can perform left rotation? Just tag the thread here, pull down in left direction, so that the tree is convected. Here you can see it is 8 and it is 6. Then here whenever you can pull down in left direction, 13 here 13, and the left of 13 is 12, right here it is right of 13 is 15. Okay, here right side is as it is, here it is 20, here it is 50. Okay, two rotations we have to perform. After performing rotation, have to check the balance factor. So the balance factor of 12 is 0, the balance factor of 15 is 0, the balance factor of 13 is also 0. Here you can see that the balance factor of 8 is, so left subtree 8 is 1, right subtree 8 is 2, so that here the balance factor is -1, here it is 0. You can see left subtree 8 is 1, 2, 3, this is the maximum 3, and 3 minus 2, that is 3 minus 2, that is 1. Here also you can see -1, here also 0. So everything is balanced. Now you can add 10. Where you can add 10? Here you can compare with 8, and also 10 will be added here. Okay, whenever 10 is added, how to calculate the balance factor? You can see the balance factor here is 0, here the balance factor is 1, here the balance factor is 0. Here you can see the balance factor left subtree 8 is 2 and right subtree 8 is 1, so that it is 1. Here you can see the balance factor of 6 is 0. Now you can see the balance factor of 8, 1, 2, 3. 8 is 3, not 2. Have to see the longest one. So it is 3. Level 1, 2 and 3. Okay, so 1 minus 3, that is -2. Again you have to calculate here. So 1, 2, 3, 4. Left subtree 8 is 4. 4 minus 2, that is 2. So here it is -1. Here it is 0. So here it is not, you can see. You can see whenever you can add 10 here, after adding 10 it is not balanced. So you can see what is the problem here. It is the right. Okay, here it is left, RL. Then you have to perform which rotation? Right rotation first, right rotation, and then left rotation. So how to perform right rotation? Here you can perform right rotation like this. Just pull down 13 in right direction. Okay, then you can see here it is a 16, it is 8, here it is 20, 50. Okay, then you can see here it is 6. Whenever you can perform right rotation, in this case here 12 become the parent here, 12, and left of 12 is 10. Okay, right of 12 is 13, right? Here 13 and 15. You can see this is the case. Next, after that, we have to perform, okay, right is there here, we have to perform left rotation, left rotation. So here you can perform left rotation. So how we can perform the left rotation? Left rotation, you can see here 16. Okay, you have to perform left rotation. That means, so just tag the thread here, just pull down in left direction. Whenever you can pull down left direction, the 12 becomes here. So 12 is the parent of 8. So here it is the left of 12 is 8. Here right of 12 is 13. Here it is 15. Right? Here left of 8 is 6. So you can see here the left of 12 is 10. Okay, now 10 is compared with the left side. Okay, because of 10 is smaller than 12, so that we have to add on left side. So when compared with 8, okay, 10 is placed in this right of 8. Okay, 10 is placed here. Then in this case you can see it is 20, it is 50. Again you have to check the balance factor. So the balance factor is 0, here 0, here 0. Here you can see it is 2, and here right subtree it is 2. That is also 0. Here also -1. Here also 0. So here left subtree it 1, 2, 3. So that is the maximum one. Okay, only 3. 3 minus 2, that is 1. Okay, so it is balanced. So that you have to add next element, that is 60. Where you can add 60? You can add 60 here. You can add 60 here. Just compare with 16. Okay, just compare with 20 and compare with 50. So 60 is added here. Okay, now we can check again. Again, I have to check. Here the balance factor is 0. Here the balance factor is -1. Here the balance factor is -2. Because left subtree it is 0, right subtree it is 2. So 0 minus 2, that is -2. Again here you can see here all are 8. The balance factor is 0. Here also 0. Here also 0, 0, 0. Here also there is no change. Here 0. Here -1 and 0. Here you can see it is 0. 1, 2, 3. It is 3. Here also 3. So the balance factor of 16 is also 0. But you can see here it is not balanced, right? It is not balanced. You can see here, because of this it is not balanced. What is the problem here? Right, 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 right. So right, right. Okay, because of right, right. Okay, it is not balanced. So that we have to perform left rotation. Right, right means single left rotation. We have to perform single left rotation in this direction, right? So that the tree becomes, here you can see it is 16, here it is 12, okay, here it is 8, here it is 6, here it is 10, okay, 13. Just note down as it is here, left subtree is not affected. Okay, it is 15, right? It is 15. Okay, next right subtree, here it is, you can perform the left rotation. That means just tag the thread here, pull down in left direction. 50 becomes the parent of 20. That is 50 here. Here it is a 50. Then it is 20. It is 20. Okay, it is 60. After performing this, you have to check the balance factor. Here it is the balance factor of 6 is 0, 8 is 0, 10 is also 0. The balance factor is, it is 2, it is also 2, that is 0. Here -1, here 0, here 0, here 0, here 0. You can see height of the left subtree is maximum 1 is 3, right? So here height of the right subtree is 2. So that the balance factor of 16 is 1. So everything it is balanced. Now we can add 21. Where you can add 21? You can see here the 21 is added here. the 21 is added here. Okay, so the balance factor is, okay, it is balanced. Okay, cannot perform any rotations, right? You have to calculate the balance factor after adding each and every element. Okay, then you can add 18. Where you can add 18 here, you can see 18 will be added. 18 will be added here. It is 18. Okay, it is also balanced. After adding 18, it is also balanced. You cannot perform anything. Then 23, where you can add 23? The 23 is added. Can compare with the 16 here, compare with 50, compare with 20. So 23 will be added right of 21, right? Here it is 21. Now after adding this, how to calculate the balance factor? It is 0. The balance factor of it is -1. 18 is 0. Here you can see the balance factor. Right subtree is it is 2. Left subtree it is 1. So that it is the balance factor is -1. Here you can see it is 0. So 1, 2, 3. Height of left subtree is 2. Right subtree is 1. So that it is 2. Okay, so you can see 1, 2, 3. Here 1, 2, 3, 4. So that is -1. So here you can see it is it is 2. Here also it is 2, 0. Here 0, here 0. Here -1, here 0. Right? Here 0, here 0. But you can see where it is not balanced. You can see that. Okay. After adding you can see that what it is the element 20. Okay, this is 21, right? But after adding 23, this, so it is the element is 23, right? Not 21, 23. So you can see after adding this one, okay, it is not balanced. You can see 1, 2, 3. Okay, here 1. So that it is 2. So because of left and right, left, right. So whenever you can see the right, so how to perform left rotation. Have to perform left rotation. After that, right rotation, opposite of L, right rotation. Here right is there, left rotation. So that here you can see the final diagram here after adding 23. Okay, left is unchanged, not affected. Okay, you can note down as it is 6. Here it is 10. Here it is 13 and 15. Here it is 13, right? You can see here it is 50, right is 60. Then you have to perform right rotation, left rotation, so that here it is 21. Okay, 21 and left of 21 is 20. 20. Okay, here it is 18. Okay, 20 left is 18. Okay, 21 right is 21 here, 21, 23, right? Here 23. After performing left rotation, you have to perform right rotation. So I have to perform right rotation. How can perform the right rotation? You can see here 16. You can see you can perform right rotation. That means just tag the thread here, just pull down in right direction. That is 21 here, and 50 is left of 21, right? Right of 21, right? So here it is 21. Here it is 50. And here it is 60. Okay. Next 21 left is 20, 20 left is 18. Okay. Then you can see 21 right is 23. So 23 can compare with 21, so that you can add 23 here. You can add 23 here. Okay, here it is 12, here it is 8, here it is 6, here it is 10. So 12 it is 13, right? It is 15, it is 15, right? Again have to check the balance factor of each one. Now how to check the balance factor? Here the balance factor is 0, here the balance factor is 0, here the balance factor is 0. Now you can see 15 balance factor is 0, here 13 balance factor is -1, right? Here the left subtree it is 2 and the right subtree it is also 2, so that the balance factor is 0. Here 16, 1, 2, 3 levels is there, 1, 2, 3, okay, maximum is 3. So here it is 1, 2, 3, okay. In right subtree is also maximum it is 3, so that the balance factor of 16 is 0. Here the balance factor of 18 is 0, the balance factor of 20 is 1, right? The balance factor of 21 is left subtree it is 2 and right subtree it is also 2, so that the balance factor is 0. Here the balance factor of 23 is 0, here the balance factor of 60 is 0. Any leaf node the balance factor is 0, because there is no left right, the left nodes, there is no right nodes, so that the leaf nodes the balance factor is always 0, right? Here the balance factor is both are equal. Here the level 1 left is it is 1 and right it is also 1, so that it is 0. So everything it is balanced, so that this is the final AVL tree. This is the final AVL tree. Okay. So in this way you have to insert any node. Thank you for watching. Please like, subscribe and click the bell icon for the latest notifications.